Okay, class, this is a problem that explains when to use the z-distribution for confidence intervals. Now, in this problem, which by the way is very rare, you would use the z-distribution, z-values to do this when you know the population standard deviation. And that's not usually the case, but here is actually a pretty good case for when you would use it. And this study was done. It's an anthropometric survey of U.S. Army personnel completed in 2012, and it was to take a bunch of different body measurements from military personnel, because they realized that I think it was in the second Gulf War that they realized that a lot of the uniforms that they had from before in stock, it wasn't that people were necessarily taller or fatter or anything like that. It was that they had more girth, or bigger bones or something. So they felt that the uniforms weren't fitting correctly. So they went and did a random sample of, this one's in the Army. They did a random sample of soldiers and took some measurements. And they knew some things from previous studies and previous uniform measurements, and that was that it had a normal distribution, and also they knew in this particular case, they knew the standard deviation of those normal distributions. So when they went to measure it again, as you would expect, they got a different mean. And this particular measurement is the distance called I don't claim to know too much about this, but it's the biacromial breadth measurement. So it's the distance between, the top of the left shoulder and the top of the right shoulder, I guess, where they would make that stitch in the uniform for the sleeves. And they tell us that the standard deviation is 1.92 centimeters, and that the mean measurement in this study in 2012 was 41.57 centimeters, was obtained from a random sample of 190 male soldiers. It says find a 95% confidence interval for the population biacromial measurement. What is the margin of error? Give, what are the conditions necessary for your calculations? Give a brief interpretation of your results in the context of the problem. I'm going to take that to mean that we want to state our confidence interval. So, and then we're going to do a sample. If the Army wanted a margin of error of only 0.1 centimeters, how many soldiers would they need to measure? So I will do all of those for you. First thing I'm going to do is, what z-value do we use in a 95% confidence interval? So let me explain where we come up with that. Basically, I'm looking at a normal distribution table, and I want the area in this, in the normal, that 95%. So I've got minus z over here somewhere, plus z over here somewhere, and I want 95% to lie in here. Well, if that was the case, that would mean I'd have 2.5% on this side and 2.5% on this side. So what z-value would give me that 95% area? Well, since these z-tables only read to the left, what I'm really asking, if I'm reading it off of this table, is what z-value would give me 97.5% to the left of the z-value. That would leave me with 2.5 on this side. They're symmetrical, so it'll be, and I don't know if you have done any of the problems in there, but where I would go is I would go here to 0.9750, and I see that that is a z-value of 1.90123456. So 1.96 is the value that's going to leave me with 2.5% on this side and 97.5% on this side. And if I went over here to this side, I should be reading for 0.025, right? Or yeah, because 2.5%. So I would go over here to 0.0250. I would see it's also at minus 1.9. 0, 1, 2, 3, 4, 5, 6. So negative 1.96 is the z value that I'm going to use in my equation. Now you can also just go to Google or something and type in, I need critical z values, and it'll give you a whole bunch of them for common confidence intervals. Like for 99% interval, you'd use 2.58, 98%, 2.33, 95%, well, the one we just found is 1.96, 90%, 1.645. So you could just go find the critical values, but I would definitely memorize a couple of these and just have them on hand, so that you don't have to look them up in the table. I'm also going to show you where to get them off your calculator. Okay, so when I come back, so that's the first part of this video. When I come back, I'll show you how to do the problem. That was just finding the critical z-value that you would need to do this problem. For a 95% interval, we use a z-value of 1.96 because between minus 1.96 and positive 1.96, 95% of the curve lies in there. Okay, I'll be back shortly.